this is Pre-Calculus Lesson 7 for Assignment 7, sections 10.7, 10.8, talking about polar coordinates. Not all of it, but the parts that basically I chose to go over. First, I want to apologize for how long last week's assignment took a lot of you. Sorry, that was not the intent. If you find yourself kind of having the same troubles with this assignment, I hope you don't. It should be easier. But if you are, right, pause. You shouldn't be spending more than 2 hours on this assignment. So if you're spending more than that amount of time, like email me, go to office hours, that sort of thing, or drop in for office hours. Let me know. We'll work through it. You shouldn't be doing a ton of pre-calc for your online work. It's supposed to be manageable. So if it's feeling not manageable, let me know and I'll work with you. Okay. So basically, what we're talking about today is polar coordinates and rectangular coordinates. We'll get more, this is learning targets right now, so going from one to the other and back. So translating between polar and rectangular coordinates, taking equations and going between polar and rectangular equations, the different coordinate systems. And then also with some of those equations, like looking at what the graph looks like and how the domain and range in one set affects the domain and range in the other set. Like if we know the domain and range in x and y, what would it be for r and theta, which are our polar coordinate variables? Okay, so let's go ahead and start talking about what are polar coordinates. So polar coordinates. So, you know when you have like x, y? So here's x and y, and let's say you've got some point, right? This has an x, y, it's got an x number right here, that's your x number for that point, and it's got a y number. Every single point on the plane, right, on a flat surface, can be mapped with an x and a y as long as you've got where the origin is, right? You choose the origin and say, oh, well, it's this far to the right, or left, and this far up, or down. And you can find like the unique placement of that point. So we can also define it, right? X, y, this is rectangular coordinates. Rectangular. Yep. And that's because when we draw this, it makes a little rectangle, right? Rectangle. Now, polar coordinates use r and theta, where r tells you the displacement or distance from the origin. So it's like this, r. And then theta gives you the angle measure, the amount of rotation from the positive x-axis to that point. So any point anywhere on the plane can be defined as its distance away from the origin, and then at what angle you got to go to get to that point. And so it's a different way of defining each point. And in calculus, when you take that next year, hopefully, you'll deal with like differentiating or integrating over like a disk where it's a circle and like a circle inside of a circle, that sort of thing. And that's easier to work with polar coordinates instead of rectangular coordinates, because rectangular coordinates are, well, better for rectangles and that sort of thing. Whereas if you're dealing with something circular, polar coordinates are nice because, well, it's defined as circular. Okay, so let's actually, if r is negative, so if this was like, let's say this is r theta, if it was negative r theta, it would just be on the other side. So it'd be 180 degree rotation, basically just flip to the other side, or like flip the angle. And also, in general, all we really need, even though r could be negative, we're just gonna focus on positive r values for the most part. And here, we can get every point on x, y by using r's that are greater than or equal to 0, and theta going from 0 to 2 pi. And some of the problems in the future, like toward the end of the assignment, you'll want to use like a negative theta to a positive theta, but we can get them all from 0 to 2 pi, but you can use any value for theta. Okay, let's actually look at an exact point. So here, I'm going to give you, we're going to say, oh, we've got this point In polar coordinates, that is 5 comma 7 pi over 6. So 5, this is polar, and we want to go to rectangular. So this is my radius. I'm 5 away from the center, and the angle is 7 pi over 6. So what we're going to do is we're going to say, well, where's that angle? We're going to go 7 pi over 6 from the positive x-axis. We can still call it x and y. So we're going to go 7 pi over 6. So we get that angle. And then we're going to go out a distance of 5. So this is the point 5 comma 7 pi over 6. Where this distance right here, that's 5. And this angle, theta, equals 7 pi over 6. And remember, right, 1 pi is, right, this is like 0, 1 pi, right, this is pi over 2, this is 3 pi over 2, just like on the unit circle. It's exactly like on the unit circle. What we're doing here is we're saying like, okay, let's say we have a unit circle, right, we're at 7 pi over 6, but then we're 5 times as far out. So let's say this is the unit circle. Let's just pretend, right? And then instead of being at 1, we're out here at 5. So now we can look at what point would be on the unit circle at 7 pi over 6. And remember how to find a point if you know its angle on the unit circle, right? The x is the cosine, right? So this would be cosine 7 pi over 6. And the y is your sine, so sine 7 pi over 6. And this would be on the unit circle, not this point. All right, this would be like x comma y. We're going into rectangular. Sorry, this is r comma theta here. So here, and this is unit circle. Sorry. I'll summarize this, don't worry. So here we're going to get, this is going to be, because it's 7 pi over 6, this is going to be negative root 3 over 2, and then negative 1/2 if you remember your unit circle. If you don't, well, you can fish out your old unit circle or look one up online and use that. Or you can just say, hey, what's cosine 7 pi over 6? Making sure that your calculator is in radian mode. And then what's sine 7 pi over 6? Make sure it's in radian mode. But I will ask for exact answers on some of these. Excuse me. So better is to use the unit circle and identify the points. Now, this is on the unit circle. Here, we're not on the unit circle. We're on a circle of radius 5. Because that r is 5. So what we're going to do is we're just going to multiply each of these by 5. So here, this point right here is going to be 5 times negative root 3 over 2. So negative 5 root 3 over 2, comma, 5 times negative 1/2. So negative 5 over 2. Now, this is like the way to think through it. What we can do is we can basically say, well, from here to here, all I did was I took 5 times the cosine of this. That gave me the x number. And then 5 times the sine of this gave me the y number. So here we're going to write out our first relationship between rectangular coordinates and polar coordinates. So x, the x number, we're going to keep this up here. X equals r cosine theta. And then y equals r sine theta. Basically, it's the exact same idea as on the unit circle, where x was cosine theta, y was sine theta. But on the unit circle, r is 1. So when we go outside the unit circle, we just say x is r times cosine theta, y is r times sine theta. Because it's basically this imaginary unit circle, but bigger, like with a radius of r, or smaller, instead of just 1. Okay. So you can just use this. You can just jump straight from here, go 5 times cosine 7 pi over 6, boom! And then 5 times sine of 7 pi over 6, boom! And jump straight there. You don't need to like sketch all this out. And then you can just put your, right, just plot your point. And the reason I want you to plot the point is so that you realize, oh, it's negative, negative, that says 7 pi over 6. It's kind of a way to double check. Okay, so that's that. That's like problems 1, 2, and 3. Now we're going to look at going the other direction, going from polar coordinates to rectangular coordinates. So I'm going to erase this and go from there. So hopefully maybe like try problems 2 and 3 right now. And we're going to keep that up there. Okay. Dry it off here. Try to get this residue out of here. It's like a bad hairstyle, a residue. You know, like a hairdo, but with, I don't know. Okay. So here we're going from polar coordinates to rectangular. Oh my goodness, that's what we did last time. We're going rectangular to polar, right? Yikes. Yeah. So here we're going rectangular to polar. So we're just going to do a couple examples. Let's say I have the point -4, 3. -4, 3. We're going to work through how we find out the polar coordinates for this. So, and then I'll give you like, we'll work through it here, and then on the next one, we'll kind of use some shortcuts. So -4, 1, 2, 3, 4, -4, 1, 2, 3. That's this point right there. Boop. And right, it's not a vector, it's just a point, but I'm drawing this in because we wanted the radius, and it's just nice to have that visual. So this is the point -4, 3 in rectangular coordinates. What we want to know is, what is this in terms of r, theta? So we need to know what's the distance from the center to the point. And in this case, for what we're doing here, we can just let r be greater than or equal to 0. You could have like, yeah, don't worry about it, just let r be positive. It's just, it could be negative, but don't worry about that. So what we're going to do here is we're going to say, well, x squared, sorry, I'm jumping ahead of myself. We want to know this distance, right? We can look at this, hey, there's a little triangle here. Distance 4, distance 3, right triangle. Oh, look, 4 squared plus 3 squared equals r squared. So I can say 4 squared plus 3 squared equals r squared. That's 16 and 9, which is 25. Right, so r equals 5. So here I get 5, comma, and I'm going to stop right there before I find theta. And I'm going to look at this. What I did is I said x squared plus y squared, and it wouldn't have mattered had I gone -4 squared, right? Because if it's -4 squared, it's -4 times -4, which would be a positive 16, still works. So we get 4 squared plus 3 squared, -4 squared plus 3 squared. X squared plus y squared equals r squared there. So that's another way to go between them. X squared plus y squared equals r squared. That's something else that we know. We know that relationship here between x, y, and r. Now let's look at theta. So we got to find theta there. Theta is this angle, right? Theta. And we have this triangle where the x is 3 and the y is 4. So what we're going to do, the way to kind of think of this is, well, I can find this reference angle right here, right? Let's call this phi, right? I can find that reference angle, and then I just go pi minus that angle to give me theta. So what we're going to say is tangent of phi, tangent of this angle, is going to be the opposite over the adjacent. So 3 over 4. You can put -4, it doesn't really matter. Just make sure when you're doing this, go -4, sure. Make sure when you are doing this, you're identifying like what that angle is and what this angle should be. Okay, like this, we'll get to. So now, tangent of that equals that, so we're going to go phi equals inverse tangent, arctangent, of -3/4. In this case, we're going to need to use a calculator, make sure it's in radian mode. So we're going to go inverse tangent of -3 divided by 4, and we get about -0.644. About. Right, it's 0.6435. Now, had we, let me quit this out, had we just gone tangent of, inverse tangent of 3 divided by 4, positive, we'd get the positive of that. So now we gotta say, okay, well, it's gonna be pi plus this, or pi minus 0.644. Because this angle is going that way, 0.644. If I want theta, theta is this angle right here. So theta is going to be pi minus 0.644. And then we can use our calculator for that as well. Pi minus 0.644. And that gives us about 2.5. We'll round it up to about 2.5. 2.50. And this is in radians. Radians don't need to have pi in them. They just need to be a number. It's just when we have those nice unit circle angles, right? That's when we're gonna get our pi's and that sort of thing, like the root 2 and the root 3 and all those. Okay, so now let's look at this and let's try to make a relationship here. What if I take, and I want you to do this with me, tangent of 2.5, and I'm going to say 2.49, or let's just say 2.5. Tangent of 2.5 is what? We're going to go tangent of 2.5, and we get almost, maybe you can see this, I don't know if it's going to work, it's going to zoom in or not, or focus, we get almost negative 0.75. Right, it was about, if we round, it's negative 0.75. Look at that. Like, that's that negative 3/4. So here we've got another relationship here, and because we rounded, we didn't get the exact answer, but the relationship is tangent of theta equals y over x. In other words, tangent is the rise divided by the run. Because remember, tangent gives us the slope of the radius on the unit circle. And the slope is the y divided by the x. Because every point that we're going to work with starts at 0, 0. So that, like, the change in y over change in x is just your y number divided by your x number. Cool. So here we've got this relationship, x squared plus y squared equals r squared. And we have tangent theta equals y over x. Using this, we got to be a little bit careful though. Okay, but we've answered this problem. We're going to do one more, and we're going to give exact answers here. And this one on your, if you get something like this, it's going to say round. And I want you to round to 2 decimal places like this. It was 2.497, so I rounded it to 2.50. So it's round to 2 numbers after that decimal point there. All right, let's look at the next problem. Here we've got negative 5 root 3 over 2, comma, negative 5 over 2. Oh my goodness, that's the same problem as we had before. I'm going to switch it even though it's different than what I had on my, slideshow I didn't give enough thought to, I guess. Bear with me. My apologies. Let's just make it negative 5, comma, no, let's make it a positive 5. Sorry. And then let's go 5 square roots of 3. I think that'll be fine. Yeah. Negative that. Yeah, there we go. Cool. All right. Let's make them both negative. Yeah, let's do that. Regardless, just go with it. Okay. Sorry. Okay. So this is rectangular. We want to go to polar. So in doing so, we're going to say, to find the r value, we're just going to go negative 5 squared plus negative 5 root 3 squared equals r squared, right? Just use that. Boom, straight with it. So negative 5 times negative 5 is 25 plus negative 5 times, so here I'm going to square both of these. I'm going to square negative 5, which is going to give me 25. I'm going to square the square root of 3, which is going to give me 3. And then that's going to equal r squared. So here I've got 25 plus 3 times 25. 25 plus 75 is 100. 100 equals r squared. So r equals 10. Cool, we got our r squared. Or sorry, we got our radius, we got our r. Now we're going to find our theta. In finding our theta value, we want to graph it. We want to make sure we understand what coordinate, or sorry, what quadrant it is in. So I'm going to go negative 5, and then negative 5 root 3 right there. So it's like this. This tells us that this, we'll get there, but this is going to be a pi over 3 reference angle. We know that because right here we've got pi over 4, whoops, sorry, is the root 2 over 2, root 2 over 2, right? This is root 3 over 2 comma 1/2 at the pi over 6. And here we've got the 1/2 comma root 3 over 2. And this, if I take 10 times that, I'm going to get those numbers, but positive. But we can just bear with me. We can say tangent of theta equals y over x. So negative 5 root 3 over negative 5. So here we have tangent theta equals positive square root of 3. And then we would go inverse tangent of theta, or arctangent, of root 3, and that's going to give us pi over 3. But when we're taking our inverse tangent, remember, inverse tangent only gives you these values here, from negative pi over 2 to pi over 2. So that's why we got to graph it out. Like, ooh, this pi over 3 is really right here. That's pi over 3. So we need this full angle for theta. So really, it's not theta that equals pi over 3. Theta equals 4 pi over 3. Because we're at 3 pi over 3 plus another pi over 3. So 4 pi over 3, that kind of looks like a 9. It's a 4. Okay, so in general, when you're going from rectangular to polar, use x squared plus y squared equals r squared to find your r value. Just this squared plus that squared equals r squared and then square root, right? When finding your theta, just do a little bit of trigonometry, right triangle trig, right? Tangent of the angle equals your y divided by your x, and then just identify, hey, what quadrant it's in, and make sure you're using that reference angle properly. Okay, so let's move on to some equations. So sorry, that should set you up for the next few problems, and we'll go from there. So go ahead and try those problems if you want, and then come back to the video. All right. We're going to keep these up here. Hopefully those show up okay on the video, because I'm going to try to keep them up there the whole time. It'd be good if you wrote those down somewhere if you haven't done so yet. Those are our relationships that we're going to use when translating back and forth. Okay, and let's try this out. Try it. Nice. Okay. Try some new pens. Let's go with yellow. All right. So we're going to go from rectangular equations with rectangular coordinates to equations in polar coordinates. So starting with x squared plus y squared equals 81. And here we're going from rectangular to polar. So in general, whenever we're going from rectangular equations to polar equations, what we want is we want r equals something. Usually there's going to be a theta in there, but not always. Or we want like theta equals something, but in general it's r equals, we'll get to the one where it's just theta equals. Excuse me. All right, here, x squared plus y squared equals 81. So we look at what we know, and that's this stuff over here. We know this. This is something that we know. These are true statements. So I'm like, hey, check it out. X squared plus y squared equals r squared. We know that. We can substitute or replace the x squared plus y squared with an r squared. So I'm just going to take this and be like, hey, that's just an r squared equals 81. And then I was like, well, I want r equals, not r squared, so I'm going to square root both sides. Square root. And because we just care about the r's being positive, we don't have to worry about the plus minus. And we can just say, well, r equals 9. And that's our equation. That's it. It's lovely. That's as simple as that. And now if you think of this, this is the equation of a circle with radius 9 centered at 0, 0. This just says, hey, radius is 9. Right? And it's a circle. So this is all the points that are 9 away from 0, which is a circle. Fantastic. Okay. let's look at the next problem. Next problem is x equals 6. Well, I know that x is the same as r cosine theta. So I'm going to replace the x with an r cosine theta. So this is r cosine theta equals 6. I was like, well, I want r equals, not like cosine and r, or sorry, I don't want theta and r together. So I'm just going to divide both sides by cosine theta to make it look nice. And that gives me r equals, and then I get 6, but what's 1 over, what happens when you have a cosine in the denominator? Remember, think back. 1 over cosine theta is the same as secant theta, right? So here I can say this is 6 secant theta. And boom, that's it, that's the answer. Got it, cool. So this tells me if I have r equals number times secant theta, that's just x equals number. Hey, pretty cool. All right, let's go to the next one. So here, problem C, we've got root 3 over 3, another example, times x equals y. Like, oh boy. Well, there's a couple ways you could go about this. You could replace x and y with r sine theta, r cosine theta. Right? Then you have like r on each side, cosine and sine, and you want to do a little dividing, that sort of thing. And you'd end up getting sine over cosine. And what do you know about sine over cosine? You're right, that's tangent. And look, we got something with tangent. We got this tangent relationship here. Tangent of theta equals y divided by x. So here I've got y and x on opposite sides of the equal sign. So what I can do is I can just divide both sides by x. Divide by x, divide by x. So root 3 over 3 equals y over x. And I know y over x is equal to tangent of theta, so I can replace this. That's just tan theta. So I can say root 3 over 3 equals tangent theta. But I don't want tangent theta equals, I want theta equals, since there's no r. I prefer to have r equals, but here r just doesn't show up. So what I'm going to do is I'm going to get rid of that tangent. How do we get rid of tangent? Well, we go inverse tangent. So we go inverse tangent here, arc tangent. And in this case is where it gets a little bit tricky. Actually, no, it's fine. Here, we take the arc tangent of either side. Theta equals inverse tangent, root 3 over 3. This is the one that, remember this is our slope. That's there, right? So that's going to be pi over 6. Or you just plug that in a calculator and, go from there. So that's our pi over, that's just theta equals pi over 6. That's the equation. So what it is it's this line that goes that way because r could be positive or negative. We don't have any information on r here. So theta equals pi over 6 is just this line with a slope of root 3 over 3 going through the origin. Cool. So in general, if you got x and y on opposite sides, if you can, divide to get a y over x, substitute in tangent theta, find out what theta is. Here, if it's x equals number, right, just plug it in and go from there, right? Hopefully you got it. Try the next few problems. Now, for the next part, we're going to be throwing in some bounds. All right. So, just to go ahead and try the next problems and then come back to the video. So here, as I erase this, what we're doing now is similar to what we just did. So really, really similar to those last problems. Like almost the same, really. It's just got an extra step in there. We're still starting out with a rectangular equation. And then we're finishing with a polar form equation, like r and theta. But, the rectangular equation is going to have a domain and a range in it. So, we're just going to do one example of this. And I think I have you do one or two problems in your assignment. So here I've got x squared plus y squared equals 9. Now, you should identify that and like pretty easily get the equation in polar form and know what this equation is. That's an equation for a circle, right? Circle centered at 0, 0 with radius of 3. But the tricky part here is that we have -2 less than or equal to x less than or equal to 3, and then -3 less than or equal to y less than or equal to 3. We've got this domain and range for that equation. So here, what we're going to have to do is replace this with an r squared equals 9, right? Square root, r equals 3. So that's our equation. It's kind of the easy part. What we need to do now is we say, well, what's theta going to be between? Because, well, we got r equals 3. That's it. That's our bounds for r. Now we're going to say, well, what are the bounds for theta? So here, I'm going to look at my graph of the circle with those. So I'm just going to sketch it out. And you don't always need a graph for these, but I just find it a lot easier if you sketch out the graph. So here we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It would be a circle that looks like this. Excuse my poor drawing, but at -2, there goes my pen cap. Yikes! Bouncing all over. I got it. At -2, we stop. So we've only got the x's that are between -2 and 3, and between -3 and 3 for the y's. So what I need to do here is I need to say, well, r is equal to 3 everywhere, but what are these angles? And this is when we're going to use a negative angle. What I'm going to do is I'm going to find out, well, what's this angle here? That's going to be my biggest angle. And then what's this angle down here? And that's going to be a negative angle. So we're going to go that way. So that way I can go to negative to positive. We got this cool little Pac-Man looking thing. Okay. So what I need to do is I need to identify, well, what are those points? In order to find my theta, I need to know my x and my y. So here I know that x equals 2. I don't know the y value when x equals 2. But I know that that the radius is 3. So basically I'm looking at 3, 2, y, right? I'm looking at this triangle right here, and I gotta find my y value. So I'm just using this x squared plus y squared equals r squared, or Pythagorean theorem, to say 4x squared plus y squared equals 9, right? Because 3 squared is 9.